Okay. In lecture and the recording that we did on it, we talked about interfaces. And again, interfaces are implemented and they provide the method headers that you will need to put inside the file that's implementing that interface. Well, now we're going to go on to what are called abstract. Alright, so the rule is, here I have an employee object, and here's my constructor with name, address, and number. Okay, its instance members up here, name, address, and number, of course, is for the constructor. Now, when I have any method that I would put something like abstract on, what that means is that an abstract method has no code and no curly braces. It ends in a semicolon. Now what this means is that the minute I make one method abstract, the class has to be abstract. All right, those are the rules. I can have an abstract class without abstract methods, but the minute I have an abstract method, I have to make the class abstract. Another rule about an abstract class is that I cannot directly create and instantiate an object for employee. You cannot do that with an abstract class. You have to go through a sub that inherits from employee to get it to run and create. But now back to here. Since this one is abstract, that means my sub, which would be salary, would have to have a mail check method in it. So again, I'm setting up that I want this method inside my sub, but it's up to the sub to put the code in it and decide how it's going to work. Alright. Next. So I have these three here. I have all the information for my constructor, and then I'm doing things like computing the pay, seeing if when I need to mail a check, I have my toString, and then I've got a get and a set for all of my methods. Okay, my salary extends employee. And here, it's a private double. Salary is its instance member, and now we go into inheritance. Again, the only way I can access employee to use it for an object is to go through a sub, since employee again is abstract. And again, if I had, let's say compute pay was abstract in my employee, that method, then that means that I would have to have a compute pay, and it has to override the one that's in employee. Okay. Now, as far as the driver goes with this, again, if I were to put this line of code in my main, I would get an error because I cannot directly create one from employee. I have to go through and use the salary that extends employee. Abstract is pretty straightforward whenever you're dealing with things like this. It just has a few more benefits or different types of options than interfaces do. So here I can print out either one of these by using the S or the E. So that's pretty much, I mean, it's not a real difficult concept. It just allows a little more control and structure for what you want all the subs to be able to do on a super. and I run that, I'll get, since I'm doing two salaries, then it will print out both people, Lee and Ann. Yeah. Okay. So that's abstract in a nutshell. The next thing I want to talk about is when you're dealing with instance members. Now remember, all of our instance members up to this point have been private, and each object has its own data in the instance members. So when I create S and E for my salary, well, S has 3,900 in its salary, E has 2,100. E has no idea what S's salary is, so you can't cross over. They have their own individual. But now let's say we wanted to do something that once I fill the instance member, all the objects I create have access to the data in that one instance member. So if I wanted S and E to be able to see, let's say I had number of employees. Well, that means that if I said I had S and printed out the number of employees, it would be looking at the exact same thing as E, number of employees. The way we do that is we create a static instance variable. Now I can't make it private, because private means that not everybody can get to it. So I'm making this protected, which means the package or the project can access it, but nobody outside that. Public, everybody can get to it. So here, every time salary is created and instantiated, I add 1 to the number of employees, so that by the time I get done creating S and E, if I were to come down here and I could say S dot, and on this one, let's just print. And I could tell it S dot EMP and E dot since I have made number of employee static, allowed access within the project directly, then that means that these two are looking at the exact same address in memory. So all objects have access to number employee. If I change number employee for S, it's going to change it for E. If I change it for E, it's going to change it for S also. Kind of like if I'm playing a video game and I want to know how I want to create Martians, and I want to know how many Martians I have shot. Well, then I would have to make sure and make that available to all the objects. It's just one way of saying it's not only it's only unique to an object. All objects look at the exact same address. Kind of picking up a few options here on what we want to look at. Okay, one more thing. Whenever we want to be able to directly, when we want to access a method in an object, we have to create and instantiate it with a new keyword. But if you've been noticing when we do things like math, when I don't have to create and instantiate a math object